Hello and welcome everyone. Couple of logistics for today's webinar. This is being recorded and everyone who registered will receive a link to the on-demand video. We will also post that link in the Enhanced Item Selection Algorithm Resource Center. Note that everyone is muted. If you have questions, please post them in the questions section. We will have time at the end to answer as many questions as possible. For questions we don't address live, we can follow up after the event. Again, thank you for joining us. We're going to talk today about some updates to map growth and our assessment engine with a new enhanced item selection algorithm. We want to ensure that you understand the updates and what's changing. My name is Adam Wolfgang. I'm Director of Product Management at the NWEA Division of Map Growth. I'm joined here by my esteemed colleague, Karen Lewis, who's the Director of Research and Policy and Partnerships. We're going to talk you through some of these topics here as we venture into these slides. Today's agenda, we're going to start with a description of what's changing. We want to discuss why and how we've made changes to enhance the map growth item selection. And we are going to discuss the impact, share some research about what the data shows, how test scores are impacted and why it matters. We'll also discuss our response, what resources and supports we're providing for partners through this transition period. All right, so we're making a change to map growth. We're making a change to our assessment engine that is a new enhanced item selection algorithm, which is what we're going to talk about today. We have heard that partners are interested in us making a change to our test that helps to enhance the content validity of our assessment, and we want to continue to deliver the most valid and reliable assessment that you can find. And so this is the direction that we're headed. You may hear us refer to this as ESA, which is the acronym for Enhanced Item Selection Algorithm. So either of those is fine. Enhanced Item Selection Algorithm, Enhanced Item Selection, or ESA. Let's talk a little bit about why we're making this change. The ultimate goal is really for map growth to align better with core classroom instruction, the Tier 1 core instruction your students are receiving. And this means that assessment will be more closely tied to your curriculum. These changes represent an evolution of the map growth assessment, allowing for better alignment with curriculum and instruction while retaining the ability to adapt off-grade level. This means that the test still provides that personalized assessment experience for students and adjusts to each student's level and meets those students wherever they are in their learning journey. This shift is a direct response to feedback from you. Many of you have asked for more actionable ways to use NWEA data for student placement into curricular content. And by aligning this assessment more closely with classroom instruction, we aim to provide data that's even more useful and relevant for informing your teaching and helping your students to succeed. Let's talk about the benefits of this adjusted item selection. First, we have a stronger connection to core instruction by aligning the test more closely with the classroom curriculum. The data that we're gathering is more relevant and directly applicable to the day-to-day teaching and learning. Second, we've increased the test's content validity. The changes ensure that the assessment accurately measures what students are learning at their grade level, providing more precise insights to their academic progress. And finally, we've improved the student's test experience by prioritizing grade level content. The test feels more familiar and relevant to students, reducing stress and making the assessment experience more positive. Those benefits not only enhance the value of the data for educators, but support better learning outcomes for students. Following this, we started the process of designing this new test in 2020, adding this new algorithm to our assessment engine, and our focus was on creating a robust and accurate assessment tool that would better serve our partners' needs. In 21-22, we conducted a pilot study with a small sample of volunteer districts. This pilot was crucial for establishing the validity and reliability of this new functionality, and allowed us to ensure that the new algorithm could provide accurate and consistent results before broader implementation. Following the successful pilot, we moved to a broader rollout. We have phased implementation of this enhanced item selection functionality rolling out to 18 states plus DC in 23-24, and then an additional 11 states in the 24-25 school year. The final phase of the rollout will occur in 25-26 when we roll out the new algorithm across all our partner states. We adopted a phased approach because the new algorithm is more computationally intensive, and we needed to ensure our systems could support the increased demand. In addition to updating test blueprints to align with each state's standards, is a resource-intensive process, and our phased approach allows us to carefully manage resources, ensuring system readiness and maintaining the highest standards of reliability and validity through this implementation process. Importantly, the end of the phased transition period coincides with the release of an updated norms study that will reflect these enhanced item selection tests. To create norms that accurately reflect the enhanced item selection tests, we need a sufficient amount of data from those tests, which is why norms are being released in phase 3 of our rollout as opposed to the beginning. The updated norms will also account for demographic shifts in the national population of students and changes in achievement and growth due to the pandemic and associated school closures. Let's talk a little bit about how we've changed map growth. The process is guided by, a testing process is guided by something called test blueprints. When a test goes to select an item for a student, it uses that test blueprint to ensure that all the necessary content areas are covered and that the test measures what it is supposed to measure. Essentially, the blueprint sets the rules for how the item selection algorithm picks the right items for each student. First, let's dive into the basics of how item selection works in traditional map growth. Test blueprints include 3 main rules. First, we have longitudinal constraints. This means that a student won't see the same test item within a specified time period, typically about 14 months. Second, there's a rule about instructional area coverage. The test selects items to ensure equal representation of the instructional areas within a subject. And finally, the test should present items of a suitable difficulty for students. If the student gets an answer right, the difficulty level of the item should generally increase. And if a student gets an answer wrong, the difficulty of that item should generally decrease. Now let's talk about what's new with the enhanced item selection. The enhanced item selection introduces an important new rule. It prioritizes selecting items for a student that match the student's grade level. All map growth items are tagged with a grade level based on the standard to which the item is aligned. Items that match the student's grade are considered on-grade items. With the enhanced item selection algorithm, it prefers these on-grade items over off-grade items. This change helps ensure that students are primarily tested on content that aligns to their grade level. Now let's look at some graphs that help us understand why this change matters. This figure captures the distribution of student achievement, specifically math achievement of second graders. Think about this almost as the distribution curve stacked vertically. As you can see, achievement is roughly normally distributed, and the average RIT score is somewhere around 180. Now let's line that up against how item difficulty is distributed. This separates out the distribution of items and item difficulty by grade level, ranging from kindergarten through 8th grade. This represents a pretty standard 2 through 5 math test. Notice that difficulty and grade level are certainly correlated. On average, items become more difficult as grade level increases. However, there's also a lot of overlap between grades. The traditional map growth test, the algorithm does not consider grade level when selecting items. It looks to the entire pool of possible items that closely matches a student's estimated achievement level and randomly selects one regardless of the grade the item is aligned to. For example, a student in the middle of the distribution, there are items of suitable difficulty aligned from standards from kindergarten through 5th grade. The traditional map growth algorithm could randomly grab any of those available items, which can result in the student seeing off-grade items, even when an on-grade item is more instructionally relevant for that student. With the enhanced item selection algorithm, this changes. The algorithm now prefers items that align with the student's grade level. So if a 2nd grader has a suitable item available at their grade level, the enhanced item selection algorithm will select that item first before it considers items from other grades. But the algorithm is still adaptive. Let's consider a very high achieving student in the tail of the distribution. In this case, there might be very few items at their grade level that are suitably difficult. In such cases, the algorithm will look to the items associated with the adjoining grades to help find the best item for the student. The closer, the better. So the algorithm would first look to the 3rd grade items, then the 4th grade items. On the other end of the achievement distribution, the test works similarly. If an item of suitable difficulty is not available in the 2nd grade item bank, then the algorithm will then move to the 1st grade items, and then if necessary, kindergarten items. So to summarize, the enhanced item selection algorithm adapts the test up or down in difficulty based on a student's performance, but it will prioritize items that are closer to the student's grade level content. This ensures that the test is more aligned with what students are learning in the classroom. Now I'd like to bring Karen back, and she's going to talk a little bit through some of the research we've done that helps to show some of the impact of this change. Karen?
Thanks, Adam. All right, so we've talked about how the test changed, and I want you to be fully informed now and understand how this impacts test scores. Before we even rolled out MAP with ESA more broadly in the current school year, we conducted a pilot study, as Adam told us about, with a sample of volunteer school districts. And in that pilot study, we did some comparability research to understand how scores might change, but also to study the content validity and reliability of the new algorithm. What the pilot study did was look at how scores from MAP with ESA compared to those from traditional MAP growth assessments. And we found hints there that students taking MAP with ESA showed higher average math scores compared to those taking the traditional MAP growth test. The differences range from less than 1 RIT point to over 5 RIT points, with an average increase of about 3 RIT points. With the broader implementation of the updated assessment in 19 states this school year, we now have a more comprehensive package of data to show us how changes to the algorithm have impacted test scores. And that's what I want to share with you next. In particular, we now have information on additional test seasons. The pilot study only looked at spring data. And we also can now look at the comparability of growth patterns across test seasons. So let's start by looking at reading test scores. To investigate the comparability of test scores and growth patterns with the updated assessment, what we did was analyze achievement and growth trends for the fall and the winter of the 23-24 school year. And we compared those to the preceding year, the 22-23 school year. We did this separately for 2 distinct partner groups. Those who consistently used MAP growth, traditional MAP growth in both years, and we'll call these our stable users. And separately, we looked at trends for partners who transitioned to MAP with ESA in the 23-24 school year, who I'll refer to as transition users. Examining trends for our stable users and our transition users separately helps us to distinguish the effects of the new algorithm from other potential influences on achievement and growth trends that might be changing results over these 2 years. So let's begin by looking at some trends for reading test scores for our stable users. And this helps us to establish a baseline for the typical changes we'd expect between the 2 years. What I want you to see here are that fall and winter test scores, which are represented in this graph, they're very similar, and growth patterns across those 2 seasons are nearly identical. The dotted line and the solid line that represent the 22-23 and 23-24 school year, they're sitting right on top of each other. The numbers in this figure are standardized mean differences, and they capture the mean difference between those 2 years in a standardized metric. So it's easier for us to compare across grades. What I want you to notice here is that those values are all very close to 0. Fall achievement in reading, winter achievement in reading, very similar across years. Growth between fall and winter, very similar across years. Now let's look at average test scores for our transition users. Remember, these are the folks, the partners that switched to ESA in 23-24. Notice that trends for this group are nearly identical to what we see for stable users. We see no discernible impacts of the transition to ESA in reading. This is also true for science and language usage, although those aren't depicted here. For these 3 subjects, average test scores and growth trends under ESA are very comparable with traditional map growth. Now let's switch gears and examine math data. Consistent with our pilot study, results for math differ from other subjects. Starting with our stable users again, we see that expected baseline pattern where fall and winter average test scores and growth trends are very consistent across these 2 years. In contrast, when we look at trends for partners that transition to ESA, we see some notable differences. I want to zoom in here to spotlight these trends and help really point out the differences that we're seeing. In the fall, average test scores under ESA are slightly lower compared to traditional map growth for most grades. Where declines are observed, they're very small, but they range from about 0.02 to about 0.09 standard deviations. In winter, we see the opposite pattern, and we find that average test scores under ESA are higher compared to traditional map growth. And this is consistent across all grades. The size of these increases ranges from about 0.05 to about 0.14 standard deviations. Zooming in on just a single grade, in this case, first grade, we can see more clearly that the combined impact of score decreases in the fall and score increases in the winter is a higher rate of growth compared to traditional map growth. For context, this table shows you the magnitude of those score differences in fall and winter in unstandardized RIP points, to give you a sense of how this might be showing up in your data. Fall test score differences are small, and they range from about 1.4 RIP points to even slight increases of about a half a RIP point. On average, in the fall, we're seeing about a half a RIP point decrease. However, winter test score differences are more consistent, and we're seeing modest increases across grades ranging from about 1 to about 2.5 RIP points. On average, that increase in winter is about 1.5 points. Those might seem trivial in magnitude, but we bring this to your attention because even small test score differences can result in significant normative shifts. What this table summarizes are how achievement and eventually growth percentiles, I'll show you, how those transition before and after the transition to ESA for our transition users. The shading in this table is meant to help convey the magnitude of those shifts across years. What you'll notice here is that fall achievement percentiles are slightly lower than previous years, and winter achievement percentiles are slightly higher. When we look to conditional growth percentiles, this is where the shift becomes more dramatic. And due to the combined effect of lower fall scores and higher winter scores, we're observing pretty substantial shifts in growth percentiles between the fall and winter period. These upward shifts range from 10 to 21 percentile points on average, and across grade, that works out to about an average of a 15 percentile point increase. This is averaging across all of our transition users in the 23-24 school year. Some of you might have seen larger shifts, some of you might have observed smaller. And here we've just focused on fall to winter trends. We're keeping a close eye on spring data, and we'll be giving more updates later when we've conducted that analysis. So now that you have a better understanding of the impacts of transitioning to ESA on math scores, I want to talk about the solution. But before we do that, I want to emphasize, and this is critical to remember, that the growth you're seeing in math on this new test is genuine and reflects real progress for your students. What has changed is the growth patterns in math are steeper than those that are captured in our 2020 norms. The ultimate solution here is the release of the 2025 norms. These new norms will include and be reflective of ESA data, and they'll also account for demographic shifts in the national population of students, as well as changes I know you've all experienced in achievement and growth due to the pandemic. We're working to release those new norms as quickly as we possibly can. But as you know, developing new norms requires new data. In the meantime, before those new norms are released, score adjustments are necessary to support the valid application of the 2020 norms. And that will come in the form of a concordance study, which I'll share more details about in a moment. But what I want you to know is that because we are dedicating considerable resources to updating norms and reports for 2025, our current interim solution relies on this concordance study, and our standard reports remain unchanged at this time. To get the best use out of your data in this transition period, we encourage you to use the concordance tool and the accompanying resources. And I'll talk about both in more detail next. So what exactly is a concordance study? Well, this is a commonly used method in the assessment industry that helps ensure comparability between two assessments or when a test undergoes significant design changes. For example, those of you who teach high school are probably aware that the College Board has recently transitioned the SAT from a paper and pencil test to a digital format. They conducted a concordance study to establish the relationship between scores from those two different testing modes. In our case, a concordance study establishes a correspondence between math scores derived from the traditional and the updated version of our test. This makes it possible for us to adjust math scores on the new assessment to support the valid application of the 2020 norms and to maintain the ability to make longitudinal comparisons across the transition period. I want to reassure you of the effectiveness of the concordance study, so I'm going to show you a series of quadrant plots. You've seen these kinds of plots in your data, and what they capture are fall median achievement percentiles on the horizontal axis and median fall to winter conditional growth percentiles on the vertical axis. We'll start first by just looking at trends in these quadrant plots for our stable users. Remember, these are the folks that did not transition to the updated test. I've used different symbols in this graph to represent the different years. We've got blue circles for 22-23 and green triangles for 23-24. So looking here to the quadrant plot for our stable users, what I want you to notice is that the cluster of green triangles aligns closely with the cluster of blue circles. Those two swarms are sitting right on top of each other, and this is the relationship we'd expect to see across years. Now let's look at what's happening for data from our transition users. And this is before we apply the concordance adjustments. Here we see that green cluster, which represents data from 23-24, it's noticeably shifted upwards relative to the blue cluster. And this indicates that schools that transition to ESA in 23-24 are experiencing higher CGPs than they did back in 22-23. But our concordance study adequately addresses this discrepancy. So now in the middle panel, I'm showing you what's happening for our transition users after we apply that concordance study. And after applying those score adjustments, the two clusters overlap and the data become consistent with that typical pattern we'd expect to see. So to summarize, I want to again emphasize that growth in math on the new test is genuine. What's changed, though, is the rate of growth relative to the 2020 norms. The credibility of our norms remains intact, and with appropriate adjustments to scores, the 2020 norms can still be validly applied in the interim period before we release new norms in 2025 that incorporate data from the new assessment. So next, I want to talk about the resources we're developing to help aid the implementation of that concordance study. So you can access all related resources to the transition on a webpage at nwea.org/mapesa. This page is going to serve as a centralized location where anything related to ESA information-wise or supports-wise will be linked. Our goal is to provide you with a comprehensive and easily accessible hub for all things related to the transition and helping you stay informed and supported as you go through this process. As we continue to develop and release new resources, the page will be consistently updated to make sure you have the latest information. The first set of resources I want to share with you today that we've already released include a detailed research report on score comparability, and that includes the results that I've just shared with you in more detail. And it also includes the concordance table for fall and winter test scores. What I want to talk about next is how to implement that concordance table with more detail. So there are two general categories of use cases for implementing the concordance table: adjusting practice and adjusting data. The first category is using the concordance table to adjust practice. And this involves adjusting the kinds of cut scores that you use for program placement and for determining which students are likely to be on track for proficiency. By adjusting cut scores, you can make more accurate decisions about student placement and ensure that students are receiving the appropriate level of support. The second category of use cases involves using the concordance table to adjust your data. When normative growth metrics are used for evaluation or for decision-making, it's essential to ensure that those metrics are not upwardly biased. Therefore, math scores should be adjusted using the concordance table, and then normative growth metrics should be recalculated based on those adjusted test scores. I'm going to walk through the application of both types of uses in more detail next and highlight some specific examples and best practices to support effective implementation. So first, let's talk about how to adjust cut scores that you use to place your students into programs. Adjusting cut scores is crucial for ensuring that students are accurately placed in programs that best meet their educational needs. And here's how you can do it. So this is a screenshot of what the concordance table looks like. You can find it at the Resource Center link that I shared with you. It contains several tabs. The first is a kind of instruction guide showing you the different tabs within the workbook and instructions on how best to use them. The next two tabs capture the complete concordance study. So this is very long, of course. For every grade, every test season, every RIT score, it shows you the translation either from traditional map to map with ESA or vice versa. What I want to draw your attention to today to help you figure out how to adjust your practice is the tab that is the condensed tab. So here it is in the spreadsheet. And what this condensed tab does is reduce down the full concordance table so that it just captures the RIT scores associated with selected points on the achievement distribution. What you'll see here in column D are the selected achievement percentiles that we focus on, and then column E represents the traditional MAP RIT score associated with that percentile. What column F does is indicate the comparable RIT score under map with ESA associated with that percentile. To use this table, what you would do is start by identifying the grade and term of interest. In this case, let's pick kindergartners in the fall. And then next, you're going to look for the achievement percentile that corresponds with the program placement criteria you're using. In this example, let's say a school is using the 30th percentile as a benchmark for identifying students for intensive intervention. The cut score associated with this benchmark under a traditional map is a RIT score of 133. If you're using map with ESA, that cut score should get adjusted to 132. To take another example on the opposite end of the achievement spectrum, we know schools often use the 95th percentile as a benchmark for identifying students for talented and gifted services. So in this case, the cut score associated with this benchmark under a traditional map is a RIT score of 160. Under map with ESA, this gets adjusted to 161. Notice that the spreadsheet is filterable, so you could select just the 30th or just the 95th percentile, and then you would see only those concorded RIT scores at that achievement percentile for all grades and all terms that we have included in the concordance study at this time. It's important to make sure you're looking at the right test season. Remember that we do see a seasonal pattern here to how ESA is impacting test scores. On average, fall scores are slightly lower, winter scores are slightly higher. So in the concordance tables, you'll see that the equivalent fall ESA scores are slightly lower than unadjusted scores, and winter concordance scores are slightly higher. Now, these score differences under map with ESA are small in magnitude, and you'll typically only see slight variations in the adjusted benchmarks compared to the original benchmarks. We still recommend utilizing the adjusted benchmarks to ensure the most accurate possible placement decisions. Now let's talk about another use case where you would adjust your practice, and in this case, determining which students are on track for proficiency. So in this case, we'll go back to the screenshot of the concordance table, and you'll notice that there are separate tabs for states. You would navigate to the appropriate state tab in the spreadsheet. In this case, we'll choose Illinois as an example. And once you're in the correct tab for your state, you'll see separate columns representing fall and winter. Column D displays the fall proficiency cut scores for traditional map, and column E displays the adjusted RIT scores for map with ESA. Column F and column G, respectively, display the proficiency cut scores for traditional MAP and adjusted RIT scores with MAP with ESA for winter. To take a specific example here, under traditional MAP growth, the cut score associated with being on track for proficiency for 6th graders in Illinois was 229. This gets adjusted down to 226 for MAP with ESA. There's no change for the winter cut score, which remains at 234. Notice again, these changes are often very small, but we still recommend using the concordance table to adjust cut scores in order to have the most accurate proficiency projections for your students. Once all partners within a state have transitioned to the updated version of the test, we'll be able to update those linking studies so that the cut scores do not need to be concorded. Now let's move to the second category of use cases I mentioned. In this case, it involves adjusting your data. What you need to keep in mind is that the concordance table must be applied to individual test scores and not to aggregated data. For example, you couldn't take a school's median CGP for a specific grade and use the concordance table to adjust that aggregated metric. Instead, you need to first adjust the underlying RIT scores and then recalculate normative growth metrics based on the adjusted data. We know this can be a cumbersome process, so to facilitate that translation, we created the MAP Growth with ESA CDF conversion tool. And this tool, the purpose is to allow you to upload your MAP growth data, and then it takes your data and applies the necessary adjustments to individual scores. Using this tool will ensure that you have the adjusted data necessary to recalculate those normative growth metrics and ensure that they are not upwardly biased. This conversion tool is coming soon. We want to coincide the release of this tool with the release of the updated spring concordance table. And the point here is for you to greatly simplify the process of adjusting individual RIT scores and recalculating those normative growth metrics. In the meantime, while we're waiting for this tool to be released, I wanted to give you a preview today of what you can expect when you use the conversion tool. Here's the data that you're used to seeing in your CDF, which is short for the combined or the comprehensive data file. And these are the fields in that file that are impacted in math by the ESA transition. What the tool will return to you is an amended CDF that includes additional columns that reflect those adjusted scores and normative growth metrics. The tool will calculate and include adjusted RIT scores for each student based on the concordance table. And then in addition to adjusted scores, the tool will also provide recalculated normative growth metrics, including things like whether the student met their projected growth projection, the conditional growth percentile, the conditional growth index. Your original unadjusted data will be preserved in that CDF. In addition to adjusting data for each student in the underlying data file, the amended file will also include new tabs that show aggregated adjusted metrics at the school, grade, and district level. And here's a preview of what you can expect from these tabs. The district level tab will aggregate adjusted data within a grade across all schools within a district. Normative metrics such as median test percentiles, median conditional growth percentiles, and mean conditional growth indices will be included. Similarly, the school level tab will provide adjusted metrics for each school within a district, including metrics that aggregate across all grades within a school as well as separately by grade. By providing both individual and then aggregated metrics, our goal here is for the amended CDF to ensure that you have a comprehensive set of tools to support data-driven decision-making at all levels. So now that we've discussed the implementation of the concordance table and how it will help you in adjusting your practice and adjusting your data, I want to give you a sense of what's coming next and look ahead to our plans. At the conclusion of spring testing, which is starting to wrap up now, we will release an updated score comparability report that focuses on fall to spring growth trends. We're hearing from many of you that you are seeing these upward shifts in your fall to spring data as well. We'll also release an updated concordance study that includes spring test scores. At this point, the concordance table only includes fall and winter. As soon as we have adequate spring data, we'll be able to update that to include all 3 test seasons. As I've already mentioned, we'll be releasing the conversion tool after the spring concordance study is complete. To accompany that conversion tool, we're also working on a data use guide. The point of this guide will be to provide step-by-step instructions for different use cases involving ESA data, ensuring that you have all the support you need to effectively utilize the new data and these tools. Finally, ESA will be released for our Wave 2 partners and our transition during the July software release. So partners that did not choose to opt out of ESA at this time will transition to the new test after that update is complete near the middle to end of June, or July, excuse me. All right, as we wrap up and before we turn to some question and answer, I want to review just the key takeaways that are important for you to walk away from this presentation remembering. First, I want to reiterate that ESA is an enhancement to the MAP growth assessment and enhances the content validity of the test and ensures that it is more closely aligned with instructional practices. This means that the assessment will better reflect your curriculum and provide more meaningful insights for educators. In the interim period before we release new norms, partners who have transitioned to ESA should adjust math scores in order to validly apply the 2020 norms. Remember, the growth you're seeing in math is genuine and reflects real progress for your students. What's changed is the rate of growth relative to the 2020 norms. If using normative growth metrics is part of your practice, score adjustments are necessary to interpret student growth against the 2020 norms. And finally, we have a range of resources available to support you through this transition. From the concordance table and upcoming conversion tool to detailed data use guides, we're committed to providing support to help you navigate this transition successfully. Thank you so much for your attention and engagement this morning. I know it was a lot of information. I want to emphasize that we're here to help you navigate these changes and continue to provide the best possible educational outcomes for your students. I know we've had questions submitted from folks when they registered from this webinar, and we've had many questions coming in during the presentation. And we'll do our best to answer all that we're possible. If we don't address your specific question live, we will be reaching out later with more information, and we'll be updating our FAQs to reflect the common questions we hear today. But Adam, do you want to start us off?
Yeah, absolutely. I have a couple of questions that have very similar theme to them. So Helen asks, what if the core instruction is happening above grade level? And Michael asks, how does the new algorithm track both on grade level and off grade level content? Are there still some items that are above and below grade level? Michael and Helen, yes. The item selection algorithm will still adjust students to above or below grade level content. We are seeing students at higher and lower ends of the achievement scale still adapt off grade level when necessary. So the test will still adapt in aspects of rigor to harder and more difficult and easier questions across the RIT scale, and it will adapt above and below the grade levels of those students also.
All right, I'll go next. And a frequent question we're seeing here is, why are we seeing ESA impacting math scores and not other subjects? Which I think is a really interesting question. And I think it boils down to the differences in the way math development happens versus development in reading, for example. In reading, we can think of progression as rather linear. Once a student knows how to read, instruction becomes about reading more complex content material, but it's rather linear once things get kicked off. In contrast, with math, it's more of a stair step. There are entire content areas within math that a student wouldn't even be exposed to until it's introduced in the appropriate grade. Think of the introduction of negative numbers, for instance. We know this frequently happens in the 6th grade, I believe, and the students before that wouldn't have seen that content. So given there's more of a gated nature to the way some math content is released to students, we think it makes more sense that tying the assessment and the items to grade level content makes MAP growth now more sensitive to the impact of instruction in that subject relative to others.
Awesome. Thank you, Karen. Another question from Jackie, will there be updated RIT scores per grade level for proficiency? And a similar question was asked from Amanda. When implemented, will this still be considered a nationally norm referenced assessment since the cut scores vary from state to state? So I want to answer those together. Again, we are working towards a norms update or national norms update in summer of 25. That update will provide not only a new reference point for normative data for achievement and growth, but it will also include updates to state linking studies and our default linking studies. So we will provide that in the summer of 25. It takes a while for us to get through the work of creating that norming study, but we wanted to ensure that we could provide that as soon as possible. So summer 25 is the time frame there. And again, we'll update not only the norms, but also the projected proficiency data in linking studies.
Another common question we're seeing here is how can we use MAP scores from traditional MAP versus MAP with ESA over the transition period to be able to compare school performance over time? Well, in this presentation, we focus mostly on using the concordance table to adjust MAP with ESA test scores to make them so they're comparable to traditional MAP growth. The reverse is also possible, and once all partners have transitioned to MAP with ESA, we can use the concordance table in reverse to adjust traditional MAP scores so they are concordant with MAP with ESA. And this will allow folks to make comparisons over time across that transition period. And we know this is important, and the longitudinal nature of our data is core to some of the uses for our partners. And so as we roll out new norms in 2025, we'll be looking for ways to provide you resources to be able to apply that concordance study to preserve the longitudinal nature of your data.
Wonderful. Chanel writes, what states are included in the 2024-2025 rollout? So there's some late breaking news here. So we have updated states that will be receiving these new enhanced item selection tests late yesterday. And some of you have seen those changes on the connection article, which you can access through that enhanced item selection resource page. The states receiving updates for the 24-25 school year will be Nebraska, Wisconsin, Pennsylvania, Maine, New Jersey, Kentucky, Tennessee, North Carolina, Oklahoma, Arkansas, and Alaska. We will work to roll everybody else over in summer 25.
I'm seeing some questions here about specifics on our timeline of when the spring concordance table will be available, when the conversion tool will be available. And we're targeting now June 14th for release of those resources. We need to wait for spring testing to conclude, and we'll cut that off on roughly June 1st and then turn those around for you as quickly as possible. So look for June 14th for a release of an updated comparability study looking at trends for fall and to spring. The conversion tool, which you'll use to adjust your data and input your CDF to get adjusted data, and then a separate concordance study that includes fall, winter, and spring data.
Seeing lots of questions also about standard reports in MAP growth. I have a question here from Shashank that says, to be clear, we have to adjust scores locally. They won't be adjusted in standard reports. And a similar question from Lexi says, is there communication we can share with parents and teachers to help them understand? It will not be clear for parents to try to understand the concordance tables. I want to talk about that a little bit. We have decided not to adjust or concord data in standard reports for MAP growth for next year, and instead work on getting a new norm study released in summer of 25. We wanted to get that new norm study finished as soon as possible. If we weren't focused on that norm study and instead adjusted or concorded data within reports, it would delay that norm study another year. So in the interest of getting that norm study out, we aren't concording data in standard reports and instead providing resources. We will provide many resources in that resource center, so keep an eye on it. We'll continue to make announcements about what's being added through our monthly partner update newsletter. The resources that are coming, we're kind of looking back to how we supported remote testing a few years ago with that resource page. Lots of resources coming, sample communications that you may use and adjust to help talk with parents, help talk with teachers, will be provided to you in the coming weeks.
I'm seeing a question about if we opt out in the coming school year, will we have to adapt to the new algorithm eventually? And yes, as Adam mentioned, we have a phased approach here. And by the 25-26 school year, all of our partners will move to the new test, and that will coincide with the release of the new norms.
Max asks a great operational question. How can we find out if we use these enhanced item selection tests this year? The name of your test will have a decimal point in its version number. We tried to keep the names pretty consistent so that we weren't causing more confusion. But if the name of your test, if it says MAP growth reading 2 through 5, Common Core 1.1, you're using one of these enhanced item selection tests. If your test name does not have a decimal place in it, you're using one of the older tests.
Anna asks, how will this impact the instructional connection with NWEA data partners? It's a great question, Anna, and our content specialists have been examining the math score differences relative to the kinds of placements our instructional connection partners use, and have determined that no special action is necessary at this time, and all placements can continue using the traditional approaches for both ESA and traditional map growth tests. This is because the placement ranges often have a band around them, and we know that the fall and winter test scores, when we look at RIT scores, are often pretty minimal. But know that when we roll out new norms in 2025, we'll work with our connection partners to update those as necessary.
We heard some questions prior to the webinar today, and I wanted to answer one of those. The question is about how this will work for states with specific state standard alignments. We will continue to align tests to your specific state standards. We use your state standards to determine grade level of each item. So as we align items to standards, we are picking up your a grade level for that item from those standards. And that is how we're deriving that. So an item may have a different grade level association in each state, depending on how your standards are unpacked. So that will still be highly configurable, highly aligned to your specific state standards.
I'm seeing some questions about the new norm study and what data will be included in that norming study. So it will not only be constrained to partners who have transitioned to the ESA test, it will still be reflective of the entire map growth partner base of national public schools. But we'll use that concordance table, the concordance study, to be able to adjust traditional map growth scores onto the map with ESA scale metrics so that we can have norms that will be reflective of ESA data.
Sarah asked a great question. If we use the new test this year, do we have to use them next year? Should we just wait until the new norms come out? And that's a really great question. I want to reinforce that the norms in 2025 is really kind of one step towards a more finalized version of norms that will come in either summer 27 or summer 28. In summer 25, we will use both enhanced item selection tests and non-enhanced item selection tests, but we'll use our concorded study to help us derive norms that are applicable to the enhanced item selection tests. We want to continue that journey by doing another full norm study using all enhanced item selection tests when we have enough data. So having people test sooner than later is better because it gets us to that second norm study as quickly as we can.
I'm seeing some concern in the Q&A about the timing of when we'll be releasing a concordance update for spring data. And I understand that's for some of you who have school calendars that are shifted earlier, that's very late for evaluating students this school year. We are targeting June 1st to cut off our deadline for spring testing data. It's still very actively happening in our partner base right now. And we'll be turning that around as quickly as we can. Helen, I see your question there. And if at all possible, if we can expedite that timeline, we'll certainly try to.
Kieran asks, if the majority of districts in my state choose not to use enhanced item selection tests this year, how will that impact the release of a linking study? Kieran, we adjust linking studies pretty regularly when needed. Oftentimes that comes with a standards update or a change to your state summative test. What we will do with norms 25 is recalibrate those based on that concordance data. And so we don't necessarily need everybody to participate. But to my earlier point, helping us get to that kind of final norming study in summer 25 or 28 will really depend on when we have enough data. So more testing is better to help us get that good base and foundation for that next norming study.
I'm seeing some questions around what happens when the new norms are rolled out and how partners can protect their historical data so that it's not confusing to teachers and students to see changes in their data. If you were with us in 2020 when we rolled out the new norms then, you will remember that we preserved the ability in your reports to toggle between the old and the new norms. We know that the transition can be confusing, and we'll be looking for ways to continue that tradition when we roll out the new norms so that you can choose whether or not you want your historical data to be evaluated under the old or the new norms.
I've got a question here, Karen, that I think I would like your support with. Once all districts transition to the enhanced item selection tests and the 2025 norms are released, should we continue to use concordance study? Will that need to be used once we have those new norms in place? And I expect there is a scenario where maybe looking at longitudinal data might need to potentially use a concordance study, but norms will be essentially backwards compatible. So could you say a little bit more about that?
Sure. So once the new norms are released, prospectively moving forward, there will be no need to use the concordance study to evaluate your current metrics. The use case for the concordance study, if you want to look backwards and be able to preserve the longitudinal nature of your data and not have a disjointed point across transition for your math scores, then you would apply the concordance study retrospectively to align your traditional math growth scores with your ESA metrics to be able to preserve that.
Great, thank you. I'm noticing another question here from Adam. Are there tests that did not include the enhanced item selection algorithm either last year or maybe this year that will be included in the future? And the specific example was Spanish reading. And the answer is yes. Yeah, Spanish reading is a little trickier because our item pools are a little smaller. So we're working through how to be able to deliver those Spanish reading tests. We're targeting 25, 26 for those tests.
Erica asks, looking to the concordance table, and there are tabs there that represent the concordance of proficiency cut scores for various states. And she says, what should we do if we don't see our state? Currently, we've included states that have already rolled out to ESA, and we'll be updating that with additional states as the rollout happens in Wave 2 and Wave 3.
Great. Question from Eric. The states that you listed rolling over in 24, 25, will automatically occur, or will it be a district choice? And it's a great question, Eric. We are going to automatically give you these tests, except that we've also sent an email for you to opt out. We want to be clear and transparent about the impacts of the data on your uses. So we're giving you a choice. So your district leader has been sent an email, and they will have an option to decline using those tests for this year. That deadline is June 1st. So an email was sent earlier this month. We'll have another one go out next week. So those are being sent again to folks in our system who are identified as decision makers within your district.
I'm combing through the remaining questions, Adam, and most of them are mostly relevant for your expertise.
Tara asks, or offered a suggestion, create a way to include scores with old norms and new norms in the same report. Tara, I think that's a great idea, especially knowing that we're moving into our first post-pandemic norming scenario. And our intent here is to provide access to you to see both the new norms and the old norms in some way. We haven't got to a solution there on what that looks like, but that is definitely going to be something we'll support.
I would underscore that point that Adam said, that that's chief of mind for us, of knowing that it's important to have new norms that contextualize current growth trends. But we know that the pre-COVID norms also are an important point of context to help you understand how your students have been impacted and how they're recovering from the pandemic. So that is a priority for us to be able to maintain the pre-COVID norms in some shape or fashion for you to be able to have that as you're tracking recovery in your district. I think maybe we have time for one last question, Adam.
Yeah, I'm looking to see if I can find one. We answered the question about concordance tables for spring. Again, we're targeting middle of June, working on that analysis right now. Question about summer school. If we do summer school in June, how will that affect student summer scores? These tests won't be rolled out to the new states until the July release, and that July release is scheduled for July 19th overnight. So if your summer school is happening before then, you will not be impacted. There are also not any norms in the system for summer, so your data wouldn't be impacted anyway.
All right, and one last question where folks are clearly interested in being able to view the recording of this webinar and share it out with other folks and stakeholders in your district. We will prioritize getting this posted to that ESA Resource Center as soon as we possibly can. You'll also receive a link directly for those of you that registered. But check that ESA Resource Center for more updates as we have them, but we'll be as communicative as we can as we have new resources to release. We're so grateful for your time and engagement this morning. We will do our best to address questions that went unanswered during the webinar, reaching out to you via your account manager or adding to our FAQs. But thanks again, everyone, for joining us. And we're here to support you through this transition.